What is radioactivity? What is radioactivity? So, what is calorie? Silence, silence now. Silence. Silence, everyone. Okay. What is calorie? Unit of? Unit of. So, what is calorie metric?
सर एक बार स्क्रीन शेयर कर दीजिए ना। सर स्क्रीन शेयर कर दीजिए एक बार।
This calorimetry. Study of measurement of ठीक है, तो इसमें अपने को पहले पता होना चाहिए कि हीट होता क्या है। So is heat and temperature same thing? What's the difference?
Heat is a kind of frequency and temperature is the measure.
Heat is a kind of one type of.
Temperature is the measurement.
Yes, great. Let us try.
Heat energy is basically the amount of kinetic energy that a particle.
Only.
The kind of energy that a atom or particle. But heat energy is a form of energy, but temperature is a measurement of a body, whether it's heat or
okay, you're getting there. Boys, any improvement on previous definition?
Yes. Heat deals with the transfer from one body to other body, but the temperature is the flow of the heat.
So the heat travels from one body to another. It is sum of kinetic and potential energy of the constituent particles of the substance. So every body has some heat energy, right? So that heat energy is the sum total of kinetic energy and potential energy of the particles of the body. Let us say this is a metal block, some solid, okay? तो क्या चाहिए AC? अब देखो ये जो ब्लॉक है इसमें क्या है पार्टिकल, सो इट विल अंडरगो वाइब्रेशंस, राइट? All particles are in a state of vibration, but at they are vibrating at their mean position. That's what leaving their location. Silence. Let me teach briefly. Okay. So due to motion, what energy they will have? Kinetic energy. Since they are vibrating, they are in motion, so they possess kinetic energy. Now, what is responsible for potential energy? The force of attraction between them. Are these particles attracting each other? Obviously, otherwise they will be able to easily break it, right? So between the molecules there exists force of attraction. But are they merging into each other because of that? That means they are holding at their positions despite of force of attraction. जब ऐसा होता है, then particle will have potential energy, isn't it? See, one example is, let's say this is ground. My palm is a ground. Okay? इस बार दोनों हाथ चलाऊंगा, बच नहीं पाएगा. My palm is a ground. Okay? So how much energy it has right now in terms of potential energy? Zero. Now I left it. Does it have potential energy? Why? Because it is holding. Something is holding. Earth is attracting it, but it is not going to Earth. I am holding it. Now it has potential energy. That's the funda. So whenever some object is held against some force like spring, you stretch it and hold it. The stretched string has potential energy. Okay? Always potential energy is in the body, which is held against some force. So in this case, it is gravitational. Okay? And in case of elastic, it is elastic potential energy. Meaning, whenever there is a force of attraction between the entities, but entities are holding at their positions, then it will also have potential energy. Clear? That sum total is called internal energy. This internal energy is heat. Okay? Now, and what is temperature? It is a physical sensation. The body which has more heat has more temperature. Okay? Now, is it always true? Let's say this body has 2000 joules and this body has only 100 joules. It is possible that this body has a temperature higher than this. The amount of energy does not determine temperature. Mind you, the amount of energy does not determine temperature, which is a physical sensation of hotness or coldness. More heat energy may have a body with less temperature, say 25 degrees Celsius. Whereas less energy body also can be at higher temperature, say 50 degrees Celsius. Now you tell me, which entity has more energy? Let's say a person or a cup of tea, which has more energy? Do you agree? Right? But when you hold a cup of tea, hot cup of tea, what happens? It is at higher temperature, less energy. See, let's say सवेरे से हम 2000 कैलोरी खा चुके हैं. अब शाम को हमको चाय पीने का मन करेगा. हमारे अंदर कितना है? 2000 कैलोरी ऑलरेडी है, प्लस और बहुत कुछ है. ये तो सिर्फ जितना हमने खाया है उसका. अब हमने चाय का कप लिया, वो कितनी कैलोरी होगी? 50-60 कैलोरी. But do we feel warm?
Yes.
So temperature decides the direction of flow of heat energy. समझ में आ गया? हमेशा हीट एनर्जी कहाँ से कहाँ फ्लो होगी? ये होता है. टेम्परेचर इज द, इट्स लाइक प्रेशर. प्रेशर जहाँ ज्यादा होगा वहां से वाटर फ्लो होगा लो प्रेशर पे. ठीक है? इट्स लाइक पोटेंशियल डिफरेंस. तो हीट में व्हाट इज द पोटेंशियल डिफरेंस इन हीट? टेम्परेचर डिफरेंस. एंड द फ्लो ऑफ हीट इज लाइक इलेक्ट्रिक करंट. समझ में आ गया? So always heat energy will flow from higher temperature to lower temperature. ये चीज याद रखो. दोनों अलग physical quantity. Since both are measurable, what is the physical quantity? Anything that can be measured. तो temperature भी एक अलग physical quantity है. Heat energy एक अलग physical quantity. Just like potential difference is different, current is different. ऐसा है. ठीक है? अब देखो, तो अब इस पूरे चैप्टर में we have to define different types of different ways which will help us measure heat and heat only, temperature का नहीं है इसका. ठीक है? तो how do we measure heat? What is the device required to measure heat? How do we measure temperature? Is the confusion clear now? Thermometer is required to measure temperature. Calorimeter is required to measure heat. ठीक है? तो चलो, तो heat measurement में heat units क्या है? तो ऐसा unit of heat energy. So since heat is energy, is joule. ठीक है? It is joule. Spatial heat unit. Is calorie. और ये हम इलेक्ट्रिसिटी वाले चैप्टर में भी कर चुके हैं, रिलेशन बिटवीन कैलोरी एंड जूल. ठीक है? So how much is 1 calorie? ठीक है ना? तो ये हो गया. And how much is 1 joule? 0.5. ठीक है? So which is the bigger unit of heat? Calorie. Now, what is the unit of temperature? So SI unit is Kelvin. Okay. Other units are? Okay. The temperature difference on the Kelvin and Celsius scale is same. The incremental temperature, like on a Kelvin scale, a 1 Kelvin rise is same as 1 degree Celsius rise. That's why delta K is equal to delta. This you have to remember. So both scales are same. What is the difference in Kelvin and Celsius? Just the reference. The Kelvin scale starts at 0 K, which is equal to -273 degrees Celsius. And C starts at 0 degrees Celsius, which is plus 273 K, which is equal to 0 degrees Celsius. So difference is in the starting reference. Okay. So this is called absolute zero. All right. So with this difference, now let us start with what is called as heat capacity. Okay. The first topic is heat capacity. This might be. What is the first topic? So the basics of heat and temperature you have already covered in height. Okay. All right. Shall I erase it now? What is temperature in Kelvin? Is equal to temperature in degrees Celsius plus 273. Actually, it is 273.15, but we are ignoring that. Okay. So this is the relation between Kelvin and Celsius. And C by 5 is equal to F minus 32 divided by 9. This is the relation between C and F. All right. Factors affecting heat energy. So, is there any relation between heat and temperature? Yes. What is the relation? Suppose the heat is indicated by Q. If you heat any substance, let's say gas पे रख दिया, okay? Water को तुमने कंटेनर में डाल के गैस पे रख दिया. अब जितना heat उसको दोगे, उतना इसका temperature क्या होगा? Rise होते जाएगा. Temperature will also rise. So whenever heat is absorbed by a substance, its temperature rises. Whenever heat is extracted from a substance, its temperature falls. Okay? So what are the factors affecting heat? So it depends on the mass of the substance. Let us say if you heat it for 2 minutes, an iron block of 1 kg, okay, and let's say its temperature rises to X, right? From the initial temperature, its temperature rises to X. For the 2 kg block, for its temperature to rise by the same amount, you will have to heat it by 4 minutes. You understand? So, the heat depends on mass of the substance. It is directly proportional to mass of the substance. For same rise of temperature, you have to actually provide different amount of heat if the mass changes, and it is in direct proportion. Second, it also depends on what is the temperature difference. Let us say this X was equal to 5 degree rise, right? So for 5 degrees Celsius rise, you have to give some amount of heat. If you wanted to raise its temperature by 10 degrees Celsius, now you have to double the amount of heat for the same substance. So the rise or the difference in temperature also matters. Okay? You want to raise the temperature to only 5 degree, some other heat will be needed. Let's say you double the amount, then double amount of heating will be done. So amount of heating we are seeing in terms of time. Okay, because rate of heat transfer is same by the source of heat. So time double करोगे तो we are assuming it is providing double amount of heat. तो समझ आ गया? So these are the two factors on which heat depends. So when you join them, therefore Q is directly proportional to M delta T. So now, when you equate it, I mean remove the proportionality, you get something called as Cf delta T, where C is called specific heat of substance. Now let us understand what is specific heat. Where C is specific heat of substance. Okay. So what is specific heat? So C is equal to what is specific heat of a substance? Look here now. Anybody remembers what is specific heat? Now they go. So if M is equal to 1 unit, rise in temperature is 1 unit, then C is equal to Q. So it is the amount, specific heat is amount of heat needed by unit mass of the substance to increase its temperature by 1 unit. 1 डिग्री सेल्सियस बढ़ाने के लिए जितना हीट लगता है यूनिट मास ऑफ द सब्सटेंस के लिए, that is called its specific heat. So just like specific resistance, specific heat for a given substance is a characteristic constant. Got it? वाटर का अलग होगा, केरोसिन का अलग होगा, हर एक सब्सटेंस का स्पेसिफिक हीट यूनिक होगा. ठीक है? तो जैसे ये स्पेसिफिक हीट है, तो दूसरा क्या चीज है? थर्मल कैपेसिटी. What is thermal capacity or heat capacity? What is specific heat we saw? This is heat capacity. Heat capacity, the symbol is C dash. And it is defined like this. You have a substance, let us say this is a block of 10 kg. You just heated it such that its temperature rises by 1 degree Celsius. So जितना भी heat लगा, okay, to rise the temperature of 10 kg block is its heat capacity. So what is its specific heat capacity? Just divided by n. The heat needed by only unit mass of it. So now we have fixed its volume or its mass. We have fixed its mass now. So that becomes specific heat. So what is the relation between heat capacity and specific heat? So therefore C is equal to C dash by M. समझ आ गया? Is the significance of specific heat capacity clear? Heat capacity is like resistance, and this is like specific resistance. What is the difference? Resistance का dimension change हुआ तो resistance value changes. वैसे ही same block, iron block 10 kg के बजाय 20 kg कर दिया तो उसकी heat capacity change हो जाएगी. अब उसको double heat देना पड़ेगा 1 degree rise के लिए. तो heat capacity change होते रहेगा same substance. लेकिन specific heat capacity कभी change नहीं होगी क्योंकि we have frozen the mass. It's always defined for unit mass of the substance. ठीक है? So in your book you have a table chart for specific heat of various substances. So highest specific heat is for hydrogen. ठीक है? And in your given table the highest specific heat is for water. ठीक है? Highest specific heat is for water. What is the meaning of high specific heat now? A body, there are two substances, one with a high specific heat, one with a lower specific heat. What does it mean? If some substances,
required to increase the temperature.
what is the meaning if I say water heat capacity is maximum? Yes, it. मतलब उसको ज्यादा हीट करना पड़ेगा 1 डिग्री राइज के लिए एज कंपेयर टू अदर सब्सटेंस. इसका लो स्पेसिफिक हीट है वो जल्दी गर्म हो, इसका हाई स्पेसिफिक हीट है उसको बहुत देर के बाद गर्म हो. समझ आया? प्रैक्टिकल सेंस में हाई स्पेसिफिक हीट वाले सब्सटेंस को बहुत देर गर्म करने के बाद फिर उसका टेम्परेचर 1 डिग्री बढ़ेगा. लो स्पेसिफिक हीट वाले को थोड़ा सा हीटिंग में ही वो फटाक से गर्म हो जाएगा. समझ आया? अब देखो टेबल में कौन सा लो स्पेसिफिक हीट है, कौन सा हाई स्पेसिफिक हीट है. क्या है? लीस्ट स्पेसिफिक हीट मतलब फटाक से गर्म होता है. क्या होता है? फ्लेमेबल सब्सटेंस को तुरंत जल जाएगा. लेवल को तो उसको बहुत ही कम है ना उसका, वो इसका डायरेक्ट एग्जांपल लेगा. तो फेस चेंज हो जाएगा जैसे कैंपर है इसका या उसको किसी चीज में मिक्स कर वो भी कैलोरीमीटर में सीखे जैसे आइस है आइस को हीट करोगे तो क्या होगा ऐड हो जाएगा उसको सीखे स्पेसिफिकली बटर हाँ वो पानी है तो बटर कर दो लेकिन वो तुम्हारे टेबल में है क्या नहीं है ना तो अभी वो सब है जो तुम आराम से सीख सको बाकी ऊपर कॉम्प्लिकेटेड होता है ठीक है तो फर्स्ट विल लर्न हाउ टू मेजर हीट एंड देन विल मूव ऑन टू कॉम्प्लिकेटेड थिंग्स दैट इज प्रैक्टिकल ओके लेकिन वो सब है नहीं अभी तो तुम फर्स्ट टाइम पढ़ो केमिस्ट्री में होगा टाइम तो ये क्लियर हो गया व्हाट इज द डिफरेंस बिटवीन स्पेसिफिक हीट एंड हीट कैपेसिटी यूनिट क्या होगा बताओ स्पेसिफिक हीट What is the unit of specific heat? Joule per kg Kelvin. So इसको Joule per kg per Kelvin. ये हो गया specific heat. Heat capacity का क्या होगा? What is heat capacity? Joule per Kelvin. इसमें mass थी. ठीक है इसको तो वैसे भी लिख सकते हो और रूल्स पर केजी पर डिग्री सेल्सियस ठीक है इसको और रूल पर डिग्री सेल्सियस आर यू फाइंडिंग दिस चैप्टर हार्ड So we are done till okay. ये वाला टेबल देखो देखिए नहीं सिर्फ वाटर स्पेसिफिक हीट ऑफ वाटर to raise the temperature of water by 1 degree 1 Kelvin, we need to heat it by 400 joules. उसमें एनर्जी हमको स्पेंड करना पड़ेगा कितना वाटर 1 kg वाटर 1 ग्राम के लिए कितना करना पड़ेगा सर 418 approximately 4180 इसको 4200 ले लेते हैं प्रिसाइज नहीं अप्रोक्सीमेट ये प्रिसाइज है ठीक है तो हम अप्रोक्सीमेटली 4200 पकड़ के चलते हैं ग्राम में कितना हो जाएगा 4.2 या तो उसको पर केल्विन लिखो या फिर पर डिग्री सेल्सियस दोनों सेम ओके Now we'll begin with calorimetry. How to measure heat? अभी टेम्परेचर मेजर करने के लिए तो थर्मोमीटर है, which is very convenient, right? हीट को ऐसे मेजर नहीं कर सकते, उसके लिए क्या चाहिए? कैलोरीमीटर, ठीक है? चलो. Which part should I erase, this or that? Now this is the device. It is a so calorimeter. Now this is a big apparatus. So it is basically a copper vessel. It is a thin copper vessel. Okay. And it is kept inside a wooden jacket. Okay. And then you have wool and cotton. ये सब क्या है? So this is wool and cotton. This is bad conductor of heat. So any hot substance kept inside, it will not, no heat will be lost in the environment because it will stop it within the copper vessel. Okay? And copper vessel is also polished from inside. So there is no heat radiation loss. Heat is lost in how many ways? Through radiation, through conduction, through convection. So what is the difference between all this? What is conduction, convection, and radiation? Are you familiar? Now, what is it? So, conduction.
Conduction is like water equals as convection. It travels through molecules like in water. It's known as convection, like in heating water, and conduction, like heating an iron bar.
Yes. So there you go. So when you heat the iron bar at one end, okay. When you heat the iron bar at one end, so iron has what? Solid particles, right? It's atom. Now look here. The heat when travels in the solid substance. What happens when you heat it? This atom vibrates more vigorously. Then it disturbs the next one. Then the next one. So this is called conduction. When the heat transfer takes place from molecule to molecule, and no molecule leaves its position. It only vibrates in all the directions, and then it transfers the heat to the neighboring molecules. Then after some time, this end will also become hot. But this is a very slow process because molecules are not moving. It is transferred. So it's a slow process of heat conduction. This is called heat conduction. No molecule transfer. Now let us say, let's say you have some liquid or water. So when you heat it, first the vessel gets heated up. This is solid, so it will conduct the heat into water. Then the water in contact with the base of the vessel will get heated up. Now those molecules, when you heat any substance, it will expand. So water at the base will expand. The density come ho jayega, so it will start moving up. Water molecules are physically moving, and they are carrying heat energy up, and this will come down. This is called convection current. So during the heating process, when the molecules actually physically move, that form of heat transfer is called convection. So fluid, like liquid and air, their heating is through a process of convection. Now what is radiation? Radiation may, let's say there is some campfire, okay? Campfire going on. You're standing here, still you feel the warmth. That is radiation. Okay? I mean, there is convection as well as radiation. Imagine there was no atmosphere. Then too you will feel the warmth. That is coming through radiation, electromagnetic radiation. Just like sunlight. Okay? So there are three ways of heat transfer. One is conduction, convection, and radiation. So to avoid conduction loss, what do? We have put this bad conductor, so it will not allow the heat to escape the vessel. So what you have is you have some mixture. Let's say you have water, and you put some hot metal cube. Okay. So water had some initial temperature T1. This metal cube had some initial temperature T2. Then at equilibrium, what we will need? We will have a stirrer for mixing it up. so that there is an even temperature achieved. So the final temperature of the mixture could be T. Okay. And to measure the temperature, we need a thermometer. Right? And then we have covered this with rubber lid. So this makes your calorimeter. So there are only two openings that also are airtight. Okay, so once you put the what do you call the components, once you put the mixture, then you can close the rubber lid. Now it is isolated from the environment. So whatever is the temperature, you will only note down in the thermometer. And this thing is kept like this. So let us say it is hanged. Thermometer is hanged. This so we will handle it by hand only. Is the construction of calorimeter understood? Now let us learn the principle on which it works. Now we have made sure that no heat escapes the calorimeter. Okay? So heat exchange will take place between the hot substance and the cold substance in the vessel, copper vessel. Yes? So what is this? This is the copper vessel. All these kind of heat losses are made sure that it will not escape. Okay? So let's now understand the principle of method of mixtures. Sure. So what is the principle of calorimeter? Heat lost by hot substance is equal to heat gained by cold substance. That's it. So heat lost so this is the principle of calorimetry. अब देखो यहाँ पे मिक्सचर में एक वाटर है, एक हॉट क्यूब ऑफ मेटल है, तो दो ही सब्सटेंस है. So who will lose heat? Hot cube. Hot cube. What will gain heat? Water. Right? So what is the formula for heat? So formula for heat by heat lost by ice. Heat is lost by the metal cube. This is and this will be there. बस कैलोरीमेट्री में तुम्हें ये रूल समझना है। ये हीट का फॉर्मूला है ना CM डेल्टा टी Q इज इक्वल टू स्पेसिफिक हीट टाइम्स मास इनटू डेल्टा टी। ये हीट क्या है? हीट लॉस है। ये क्या है? हीट गेन। अब इसमें से जो गिवन है वो सब्स्टिट्यूट करो, जो अननोन है वो फाइंड आउट करो। चेंज बॉक्स में दैट्स इट। ये मास ऑफ वाटर है, CW स्पेसिफिक हीट ऑफ वाटर। इस केस के लिए अगर ये वाटर और मेटल क्यूब है, ठीक है, M is इसका। That's it. This is your principle of method of mixture. So, and in this formula we have ignored the heating of the calorimeter vessel, the copper vessel. ठीक है ना? So if you take into account the heating of copper vessel also, because it has a very low specific heat, वो भी ऐड करना पड़ेगा। कहाँ पे? राइट साइड। the above formula. ठीक है, with the above formula, heat absorbed by copper vessel is ignored. अगर वो भी हीट ले रहा है तो यहाँ पे और एक टर्म आ जाएगा, यहाँ पे और एक टर्म आ जाएगा, स्पेसिफिक हीट ऑफ कॉपर into mass of copper into same, ये इधर भी यही आएगा, क्योंकि जो वाटर का टेम्परेचर है वही कॉपर वेसल का टेम्परेचर, so it will be T minus T2। समझ आ गया? बस ये हो गया, चैप्टर खत्म। यूनिटी क्या ऑन करना है? Now natural consequences, पढ़ो भी आगे के जो natural consequences, मतलब natural phenomena ठीक है। वैसे तो करेंगे पहले ये चैप्टर तो खत्म करो, इस पे भी एक मार्क का क्वेश्चन आता है। ये तुम लोग कर लो जब मैं बताऊं, ये तुम लोग पढ़ो पहले, अगर डाउट होगा तो फिर नेक्स्ट क्लास में क्लियर करो।
Sir,
So we'll do some numericals. Chalo, numerical. Same. जो सिखाई करते हैं ना सॉफ्टवेयर के पास तो हॉट वाटर अभी वाटर का स्पेसिफिक हीट सबसे ज्यादा है बहुत देर से गर्म होता है और बहुत देर से ठंडा होगा हॉट वाटर बैग में अगर हमने वाटर डाल दिए इस तरह का दैट विल यू कैन डू फॉर लॉन्ग ड्यूरेशन क्योंकि अच्छा हाई स्पेसिफिक हीट वाले सब्सटेंस गर्म होने में भी टाइम लगता है ठंडा होने में भी टाइम ये ठीक है 1 डिग्री टेम्परेचर डाउन इट विल रिलीज 4200 जूल और 1 डिग्री बढ़ाना है तो इट विल एब्सॉर्ब 4200 वाटर रिलीज ठीक है चलो न्यूमेरिकल करते हैं तो ये समझ आ जाएगा तो अभी न्यूमेरिकल करते हैं और इवन जल्दी करो इसमें किसी को क्वेश्चन है एनीबॉडी हैज एनी क्वेश्चन What is numerical 2 in your book? What is given? So, what is the relation now? Therefore, C dash is equal to C into M. ठीक है आपने को क्या दिया हुआ है सी क्यू ये दिया हुआ है स्पेसिफिक हीट कैपेसिटी दिया हुआ है तो ये कितना हो जाएगा कितना हो गया 410 मास 0.2 कितना हो गया 82 ये क्या है जूल पर देखिए सेकंड पार्ट क्या है इसका दिस इज ए बी में क्या है
much heat engine required to increase the temperature of the resident part of the air.
Okay. So Q is equal to CU into M हमने कितना निकाल लिया आपने निकाला है $820. How you answer? Question number
I wanted
C given है, M given है, MCRT given. बस straight forward. ठीक है? C कितना है? M कितना है? 100 ग्राम, मतलब 0.1. Delta T कितना है? 50. इतना जूल आ जाएगा. तो 0.2. ये ठीक है, ठीक है, तो स्ट्रेट फॉरवर्ड फॉर्मूला ठीक है, जो भी मेरे बुक में अलग है. Next is question 6, right? Find the time take it. We did question 2 and question 4. Now do question 6. Question 6 होगा क्या किसी का? नहीं बना तो नेक्स्ट क्लास में बनाएंगे ना. कितने बजे शाम को सर? हो गया सर. 2 मिनट. किसी को
एक बार भी जाओ